Have you ever just stopped and wondered how some things are even possible? You know, when science feels less like a textbook and more like straight-up magic? Well, today we're pulling back that curtain. We're going to dive into the incredible science behind some of the most mind-blowing facts you've ever heard.
I mean, think about it. Why don't the tires on a massive jumbo jet just explode when it slams onto the runway? And what would actually happen if you were, suddenly exposed to the vacuum of space without a suit? We are counting down 5 amazing scientific explanations, and trust me, you are going to want to stick around for number 1. It is a real stunner.
All right, kicking things off at number 5, we're talking about the unsung heroes of every single flight you've ever been on, the airplane tires. Their resilience is, honestly, just an incredible feat of modern engineering. Okay, so picture this. You've got this massive aircraft, right? It weighs hundreds of thousands of kilograms, and it hits the tarmac at speeds of up to 300 kilometers per hour. The sheer force and weight crushing down on those tires, it's just absolutely immense.
So the big question is, how on earth do they not just disintegrate on impact? What is keeping them from bursting under that insane amount of pressure, landing after landing after landing?
Well, the secret isn't just some super advanced rubber, although that definitely helps. The real game changer here is what's inside them. It's pure nitrogen. Now you might be thinking, wait, the air we breathe is like 78% nitrogen, so why not just use regular air? Well, that's a great question. The thing is, regular air also has oxygen and water vapor. Oxygen is super reactive, and that moisture, that's the real villain here. Pure nitrogen, on the other hand, is what's called an inert gas. It's dry, it's stable, and it doesn't mess around.
So nitrogen is the perfect choice for a few really important reasons. First, it keeps all that moisture out, which means the tire's steel components don't rust from the inside. Plus, way up at cruising altitudes where temperatures just plummet, that moisture would freeze and cause huge pressure swings. But nitrogen? It stays consistent. And, maybe most importantly, unlike oxygen, it's non-flammable. That is the last thing you want near a set of red-hot brakes, a tire that could fuel a fire.
All right, let's move on to fact number 4. We're leaving the tarmac and heading to the final frontier. We are going to tackle what really happens to the human body in space, and let me tell you, it is not what you've seen in the movies.
Yeah, science fiction absolutely loves the drama of a person instantly exploding or freezing solid the second their helmet cracks. It's a really powerful image for sure, but it's pure myth.
The reality is actually far, far stranger and way more brutal. See, your skin is this incredibly tough, flexible container, so it would hold you together. You wouldn't explode. But the complete lack of any external pressure would set off a catastrophic chain reaction inside your body.
So within seconds, all the air in your lungs would just be violently sucked out. You'd lose consciousness in about 15 seconds from lack of oxygen. The moisture on your eyes and on your tongue would literally boil away. Then, the nitrogen that's dissolved in your blood would start to form gas bubbles, causing your entire body to swell up. It's a gruesome condition called embolism. So no, you wouldn't pop, but your heart would stop after about 90 seconds. It's a grim but scientifically fascinating reality.
Coming in hot at number 3 is a fact that connects the most glamorous gemstone on Earth with one of the most boring, common items probably sitting on your desk right now. Get ready to rethink everything you know about diamonds.
Just look at this thing, a brilliant, perfect diamond. It's one of the hardest materials known to man. And you know what it's made of chemically? It's incredibly simple. It's just carbon. Okay, now think about the pencil you use to write or draw. That soft gray stuff in the middle, that's graphite. And guess what? It is also 100% pure carbon, the exact same element.
So, how? How can the exact same element create both one of the softest materials we know and the absolute hardest? Well, it all comes down to the atomic structure. In graphite, the carbon atoms are arranged in these flat sheets that can easily slide right past each other. That's what makes it soft and smudgy. But in a diamond, those same atoms are locked into an incredibly strong, rigid 3D lattice. And this structure is forged under immense heat and pressure, deep, deep within the Earth, turning humble carbon into a brilliant diamond.
For our number 2 fact, we are heading to the coldest waters on the entire planet, Antarctica. Because here, we're going to find a creature that completely defies the laws of biology, just to survive in what should be an impossible environment.
The seawater in Antarctica can drop to a bone-chilling -1.9 degrees Celsius.
Now, a typical fish's body fluids, well, they'd freeze solid at around -1 degree. So this presents a really cool biological puzzle. How do these fish not just turn into solid fish sickles?
The answer is a legitimate biological superpower: antifreeze proteins, or AFPs for short. These incredible molecules circulate all through the fish's blood, and what they do is they latch onto any tiny ice crystals that start to form, and they physically stop them from growing bigger. It's literally like having a natural coolant system running through your veins.
And this isn't just some theory. Way back in the 1970s, a biologist named Art de Vries made this landmark discovery. He's the one who found these unique proteins that effectively lowered the freezing point of the fish's body fluids, allowing them to thrive in water that should be completely lethal. It's just an amazing example of evolution in action. And here we are. We've made it to fact number 1. We've traveled from the runway to deep space, from deep inside the Earth to the Antarctic seas. But for the most mind-blowing fact of all, we need to look inward at the incredible machine that's sitting inside our own heads. So what is the storage capacity of the human brain? Well, according to neuroscientists, the best estimate we have is a staggering 2.5 petabytes.
Now, to put that number into perspective, 1 petabyte is 1,000,000 gigabytes. So 2.5 petabytes, that's enough digital storage to record 3 million hours of television. You would have to leave a TV running nonstop for more than 300 years to fill up that much space. And you have that power, that capacity, right between your ears.
So there you have it, from nitrogen-filled tires to antifreeze fish and the absolute supercomputer that lives in your skull. We've covered some truly incredible science today. Now I have to ask you, which one of these facts blew your mind the most? Let us know down in the comments.
And hey, if you enjoyed this deep dive into the science of the impossible, make sure you're subscribed to the channel. We have plenty more explainers just like this one coming your way. Thanks for watching, and we'll see you in the next one.